Welcome to Module 4.2, where we'll dive deep into Ethereum's account model, how it contrasts with Bitcoin's UTXO model, and its pros and cons. To understand Ethereum's account model, let's first grasp how traditional bank account systems operate. Your bank's ledger identifies you, your transactions, and your balance, updating each time you make a transaction. For example, if you send Bob $10, your bank will deduct $10 from your balance and add it to Bob's account. Banks keep a vast database of user balances and information on each account holder's identity to keep track of who owns what. So what does this have to do with Ethereum's account model? Well, Ethereum takes this age-old system to new heights. Ethereum is a decentralized protocol that isn't controlled by centralized parties like banks. Its account model facilitates Ethereum's extensive capabilities, from token transactions to smart contract operations. Moreover, Ethereum's account model keeps track of users' available Ether balances in a way distinct from Bitcoin's UTXO model. Here's how Ethereum's account model works. Ethereum has two types of accounts. The first type is called externally owned accounts, or EOAs, which are controlled by anyone with private keys. The second type is called contract accounts, which are smart contracts deployed to the network and controlled by code. Both account types can receive, hold, and send Ether and tokens while interacting with smart contracts deployed on the network. But there are a few key differences between them. EOAs are essentially user accounts that are free to create and can initiate transactions. But creating contract accounts incur costs, and they can only send transactions in response to receiving a transaction. In other words, interactions with a contract account need to be triggered externally by an EOA or a contract that sends a transaction to the contract's address. The account model revolves around three essential components. First, the Ether balance represents the value held by an account. This is easy to understand. Let's say Alice's account has 10 Ether. This balance gets updated each time Alice sends or receives Ether. Second, every transaction in Ethereum involves the transfer of Ether from one account to another or the execution of a smart contract. Remember the concept of nonces? Each EOA has a key component called a nonce, too, which is a counter of transactions sent from the account, ensuring transactions are processed in order. This is crucial for preventing double spending. Finally, each Ethereum transaction requires computational resources to execute, and each transaction requires a fee, called gas. Gas has to be paid regardless of whether the transaction is successful or not. Gas ensures network sustainability by discouraging spam and inefficient code. Now, let's get to one of the core concepts of the account model: smart contracts, which make up Ethereum's contract accounts. Smart contracts are deterministic computer programs that run on the blockchain when certain conditions are met. They are self-executing agreements with the terms of the contract directly written into code. They eliminate the need for intermediaries and allow for trustless transactions. A unique aspect of Ethereum's account model is the ability of EOAs and contract accounts to interact with each other. This interaction forms the backbone of Ethereum's decentralized apps. A related key concept to understand is state. Ethereum is often called a state machine. The state is the current information of all accounts. Transactions cause changes in the state. For instance, transferring Ether from Alice's account to Bob's account will update the state. All these state transitions are bundled into blocks and added to the Ethereum blockchain. Every node on the Ethereum network stores a copy of this blockchain, making it decentralized and secure. Driving these operations is something called the Ethereum Virtual Machine, or EVM. You can think of it as a universal runtime compiler where all smart contracts are executed. On the other hand, Bitcoin utilizes the UTXO model. Every Bitcoin transaction consumes a certain number of UTXOs as inputs and generates new UTXOs as outputs. It's akin to spending cash and receiving change. The UTXOs, being immutable and indivisible, ensure transaction integrity. A Account state isn't a relevant concept in the Bitcoin network as transactions are independent and connected only through UTXOs. The Ethereum account model has had profound implications for the cryptocurrency industry. It paved the way for dApps, enabled the development of DeFi protocols, led to the proliferation of initial coin offerings, introduced NFTs, heralded scalability innovations like rollups and sharding, helped create various token standards, and reshaped the entire blockchain landscape. Like all of the key crypto concepts we've discussed in this course, the Ethereum account model also has its benefits and disadvantages. It's Turing complete, enables complex operations, allows direct value transfers, and offers direct account-to-account interaction. But it's also prone to certain attacks, suffers from scalability issues, and is very complex. Despite these challenges, Ethereum's account model stands as a revolutionary approach to blockchain-based decentralized computation. And with ongoing advancements, Ethereum continues to evolve, promising a future full of potential. Let's conclude this module by exploring the all-important question: why does Ethereum use the account model while Bitcoin uses the UTXO model? Historically, the models reflect the unique visions of Ethereum and Bitcoin. While Bitcoin aimed to create a decentralized digital currency system, Ethereum sought to build a global, open-source platform for decentralized applications. Ethereum's account model enables this complex functionality, while Bitcoin's UTXO model serves as a robust foundation for a digital monetary system. The choice between the two is not a matter of superiority, but a reflection of their unique visions and the specific use cases they serve. As blockchain technology continues to evolve, these models will inevitably adapt, bringing forth new possibilities in the revolutionary world of decentralized systems. In the next module, we'll examine Ethereum's tokenomics and how they have evolved over time.